page 80. Elements with 3 or fewer valence electrons. Hopefully you guys all know that if there are 3 or fewer valence electrons, does that atom lose electrons or gain electrons? It loses electrons. What type of elements have 3 or fewer valence electrons? What type of element? Metals, yes. And if they lose electrons, what charge do they become? Do they become positive or negative? They become positive, okay? So that's our cation. So metals are going to become cations because they have a small number of valence electrons. And hopefully you already knew that because we've done that in the Bohr model and things like that. Today, the only thing we're going to change about this is we're going to look at how to do this for Lewis dot structures. Okay, so we are going to take, oh, and there's a couple other things I wanted to mention here. If we have a charge which is +1, the most correct way to write that is simply as plus. Okay, I'm actually going to write this over at the side because I think maybe it'll be a little bit clearer. So if you have a +1 charge, writing plus, that's the best. Writing 1 plus, second best. And writing +1 is okay. So what would I prefer you to do? I prefer you to write plus. Am I going to take marks off if you do either of the other ones? No. Okay? Similarly, if you actually have a number other than 1 with your charge, 3 plus would be best. +3 would be okay. Yes? So 3 plus is what a chemist would do. +3 is what you might do if you don't remember to be like a chemist on that particular day, which, you know, is not the end of the earth. All right. So here we have a sodium atom. It has 11 protons and 11 electrons. You can see it has this 1 electron in its outer shell. It is going to lose 1 electron, and then we draw brackets around it and the charge once it loses that electron. So the only thing we're doing that's new here is we're saying let's get rid of all the circles and the core electrons, and we will just draw the valence electron. This is the Lewis structure. So we've really simplified it. We just have that outer shell and we've just drawn a single electron there. What happens? We lose that electron and we are left with Na, because it is not just, because it's a Lewis structure though, we put brackets around it and we put the charge. Yeah. My watch is telling me it's time to be more active, but we'll have to wait until after the lesson. Okay, magnesium. Here we have magnesium. It has 2 valence electrons. That's our magnesium atom. In order to become stable, it is going to lose 2 electrons. And it becomes, and we put, of course, the brackets and the 2 plus. So that's how we do it for a Bohr model. And the only thing we do different for the Lewis dot structure is we get rid of all the circles and the core electrons. So really all we have is 2 electrons. Would it be okay if I drew it like this? Would that be okay for magnesium? Yeah. Would it be okay if I wrote it like this? Yes. Would it be okay if I wrote it like this? No. Okay, because they can't pair up. All right, but anyway, doesn't matter because we're going to actually lose both of them, okay? And then we write the brackets and the 2 plus. Now, what if we had a nitrogen atom? Let's do a Lewis structure for this. Just do the Lewis structure. Nitrogen is in group 15. 15. How many valence electrons? 5. 1, 2, 3, 4, 5. So when it becomes an ion, is it going to gain electrons or lose electrons? It's going to gain how many? It's going to gain 3 electrons. There's our original 5. And then I have an extra 1, 2, 3. What would I have to do to finish off this ion? Brackets and a charge, so that would be brackets, and then what would the charge be? 3 negative, okay? And what would we name this ion? That would be nitride, because non-metal ions change their ending. Is good? All right, and that's really it. That will allow you to happily probably do all of 81 to 84. We'll go over anything from there that you have questions on next day. Okay. So yeah, your homework, 76, 78, 79, 81 to 84. We still have 10 minutes left, so keep working. And if you're studying for tomorrow's quiz and you want extra practice on average atomic mass, pages 65 to 68. Okay, that's for tomorrow's quiz. Excellent, thank you.